Running code, which is not normally that much of a problem, but running random code. So IRC, that's kind of a hostile environment. And it's, well, maybe not IRC, no problem, but you know, it's nice really. But anyway, here we are. We're in IRC. Here's a bot. You talk to it. It runs Perl. And that's simple. That's just a bare word. Now I'm asking it to match regex, which is matching foo, so that does match. Then if I can wrap it with some brackets, then it will give me an array ref and give me the captures. It doesn't, however, let me run ls, because that would be scary. But we'll get to that in a bit. So it also remembers stuff. So I give it a subroutine here, and it remembers subroutine and runs it. It will also deparse it and show me what happened. It also is a karma bot, because why not? It remembers, it treats those as Perl variables, and you can mess with them and do stuff. But whatever, you know, it's kind of fun. So, yeah, I wrote that a few years ago, and a few friends played with it. I didn't really tell too many people about it, because I didn't really trust that it was that secure, but it was probably secure-ish. So, how did it work? So, safe is the main thing it used, and then this is the kind of initialization, commits certain operations, deny bless, because if you use bless, you can bless an object with a destructor, and then the destructor runs outside the safe thing if you're not careful. A few other scary things. It uses storable, so that's how it keeps things around. It just saves them to a file using storable, which is configured to serialize code refs and stuff. And then it just reads that file down here and just chucks it back into the compartment. It's not pretty, and kind of fragile. It broke on 5.16, I think, because they wrapped something in a different way, so I had to hack save to make it work again. That was kind of nasty. So virtualization is the new shiny, but I really need lightweight virtualization rather than some complex sort of, I'm going to spin up a whole VM just to run someone's untrusted code and then get rid of it. So LXC is what's behind Docker, which is kind of one of the new shiny things. But LXC, it turns out, is also a bit complex and has a bit too much overhead. So yeah, not known enough. So what I actually use is namespaces, which are the thing behind LXC. And this is using a very simple program called contain, which is on GitHub somewhere, Linux at the end. And basically it just uses Linux kernel namespace support, which means it can create here a new kid namespace. So when I run this, you'll see that running as user IRC is a command. So the command in this is the thing at the end. So I'm running ps aux, and if you look closely, you'll notice that the PID is 1. So this actually is running it as a new entire process area thing that the kernel knows about, and it can't get out of that. Now, it's actually not constrained by anything else, so it can still see the rest of the file system, except it can't because this option means chroot. So it's a bit like it's using chroot, and then it's also not letting it access the normal process IDs. So, but it can still access the network. So there are still some things you can do to escape this. So there's actually a few other namespaces. So along with namespaces is something called cgroups. So cgroups lets you sort of group together a set of processes and things. Systemd, if you're familiar with it, under the hood uses cgroups to limit the things that your program can do and stuff. But here I'm setting a limit on memory in bytes to 10. Still running this in the chroot, and now I'm running Perl and constructing a rather long string. So I run this, and it says 9. So what 9 actually is this echo thing at the end. And you'll see here it's actually cured Perl. This is the kernel saying it cured Perl because it was out of memory. Because the limit in the kernel was 10 megabytes. So yeah, that's kind of interesting. So you can basically, with this and combining some other things, create a container that is basically a virtual machine, but it's done at the kernel level. So that's how Docker and things do it. There's a really new interesting feature called config user. And using this, you can basically configure as a normal user all this stuff. So you don't even need to be root on the machine to have a virtual machine running as root as far as the kernel is concerned. But it's another sort of level down, so it's actually isolated, provided there are no bugs in the kernel. This is really scary. So I thought, oh, this is cool, this is new. This is in 3.8, which was the first kernel release with it, but no. Ubuntu don't enable it. Maybe they're wise, I don't know. But anyway, recompile kernel, blah, blah, blah. So now I actually have something that gives me a very simple thing here. I can run system, ls, and stuff. I can also run ifconfig. And it doesn't give me anything because there are no network interfaces, except actually, if I look closely, there will be a non-configured local host. Sorry, move back. But yeah, so with this, basically, I've got a container that in theory, normal user can create. As it turns out, I haven't actually compiled the kernel, so I'm not using that. But, you know, it's doable. So here are some links. That last one for the slides doesn't work yet, so I haven't got around to it, but it will at some point later. Read about namespaces on Linux we can use, they're cool. And look at the other things, because they're also cool. Thank you.